Welcome to part 3, solving for the zeros of the polynomial function. You're learning with teacher Jen. This time we have the example p of x is equal to 2x raised to 4 minus 7x cubed minus 12x squared plus 23x plus 6. Notice that we have a complete polynomial starting with exponent 4, 3, 2, 1, and 0. Before we can solve for the zeros, let's identify necessary information. We have the degree of the polynomial denoted by n. That is the highest exponent of x, which is 4. And according to the fundamental theorem of algebra, the degree of the polynomial is equal to the number of zeros. The number of zeros may be repeated. So we say that we're looking for 4 zeros as the degree is 4. Then we take note of the constant term denoted as a sub 0 and the constant term is 6. This will give us the p-values plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, the factors of 6. We also take note of the a sub n or the leading coefficient, which is 2, giving us the q values. What are the factors of 2? Plus and minus 1, plus and minus 2. Then, all the possible rational zeros, the p divided by q. All the p's 1, 2, 3, and 6, when divided by 1, will be the same to be plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. Then 1 divided by 2 is not yet on the list, so we write that down. 2 divided by 2 is 1, no need to write because no repetitions. 3 divided by 2 is not yet on the list. Then 6 divided by 2 is 3, is already on the list. So how many possible rational zeros are we looking for? 1, 2, or are we going to test? 1, 2, 3, 6, 1 half, and 3 halves comprising 6 times 2, 12 possible rational zeros. But we are not going to check all 12. We are going to make use of the depressed solution. And we use synthetic division for that. So we write on the first row all the coefficients of x in descending power. Then 23, then you have there 6. Let's check whether negative 2 is a rational zero of p of x. Thus, we have bring down 2. 2 times negative 2 is a negative 4. Plus a negative 7 is a negative 11. Times a negative 2 is a 22. Plus a negative 12 is a 10. Times a negative 2 is a negative 20. Plus a 23 is a 3. Times a negative 2 is a negative 6. And yes, we arrive at a remainder of 0, meaning to say negative 2 is a 0 of p of x. So, from this fourth degree, we have depressed the solution or the equation to a third degree. And of course, we still cannot factor a third degree polynomial. So let's test also whether 2 is a repeated 0. So for the second time, we have 2 times a negative 2 is a negative 4 plus a negative 11 is a negative 15 times a negative 2 is a positive 30. And from here already we can see that 40 times a negative 2 gives us not 3 or a negative 3, so we can arrive at 0. Thus, 2 is not repeated 0. So we check. What about checking for 1? So we have bring down 2. 2 times 1 is 2. Plus a negative 11 is a negative 9. Times a 1 is a negative 9. Plus a 10 is 1 times 1 is 1. And 3 plus 1 is not 0. So 1 is not a 0 of the polynomial. Let's check for another. Say, for example, we have 3 halves, the fraction 3 halves. To make our work easier, for the denominator that is telling us that we have to divide by 2. For the numerator, it's telling us we multiply by 3. So that is our guide. So we bring down 2. 2 divided by 2 is 1. Times 3 is 3. Then plus a negative 11 is a positive 8. Then 8 divided by 2 is 4. Times 3, oops, that's a negative 8, sorry. Negative 8 divided by 2 is a negative 4. Times 3 is a negative 12. Add that to 10, giving you a negative 2. Negative 2 divided by 2 is a negative 1. Times 3 is a negative 3. We arrive at the zero remainder, which tells us that 3 halves is a zero of the polynomial. This is already our second degree equation. Since we already have a second degree, then we can solve by either factoring, if possible, or by the quadratic formula. And the quadratic formula solves any quadratic equation. So we write the equation to be 2x squared minus 8x minus 2 is equal to 0. And notice that 2, negative 8, and negative 2 are all divisible by 2. So, reducing this, we divide all by 2, left side divided by 2, right side divided by 2. And we arrive at the equation 2x squared divided by 2 is an x squared, minus 8 divided by 2 is a 4, 4x. Negative 2 divided by 2 is a negative 1 is equal to 0. And we can see here that x squared minus 4x minus 1 is not factorable because take a look at the last term, negative 1. You cannot come up with factors of negative 1. That will sum up to a negative 4. So what are we going to do? We make use of the quadratic formula. The quadratic formula being x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. If you have forgotten how to solve quadratic equations using the quadratic formula, you can go back to the video on this lesson, solving quadratic equations by the quadratic formula. So again, we identify what is the value of A, what is the value of B, and what is the value of C. So A is 1, you have B, which is negative 4, and the C, which is negative 1. And we do the necessary substitution here. X is equal to the negative of B, which is negative 4, plus or minus the square root of B squared, which is negative 4 times raised to 2, minus 4 multiplied by A, which is 1, and by C, which is negative 1, and divide this by 2 times 1. We do the necessary simplification. Thus, we have negative and negative is positive 4 plus or minus. What is the square root of negative 4 squared? Negative 4 squared is 16. Negative 4 times 1 times negative 1 is a positive 4. And underneath, we have there 2. Giving us now the value 4 plus or minus 20 can now be rewritten as 16 plus 4 is 20. The square root of 4 multiplied by the square root of 5, that is your 20. But we apply the laws of radicals so that we can come up with a perfect square factor, which we can extract its square root divided by 2. So that x will now be equal to 4 plus or minus was the square root of 4. That would be equivalent to square root of 4 is 2. Then you have times the square root of 5. We cannot extract the square root of 5. That's an irrational number divided by 2. And as we can see here, 4, 2, and 2 are all divisible by 2. So we factor out 2 in the numerator. That would be 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, times the square root of 5, and then we have here divided by 2. So that we can say 2 divided by 2 is 1, giving us x is equal to 2 plus or minus the square root of 5. So we now have the zeros. First value, 2 plus the square root of 5. Second value, 2 minus the square root of 5. Thus, if we have to list down all the zeros, I will make use of the possible spaces here. So what are the zeros of the polynomial function? We start with the first two rational zeros. That would be negative 2 and 3 halves. And then we have here the two radical roots or the irrational roots. You have 2 plus the square root of 3, rather the square root of 5, and 2 minus the square root of 5. So 1, 2, 3, 4. There are 4 zeros wherein they are all real, no repetition. 2 are rational, 2 are irrational. So we have here, ladies and gentlemen, the third example for the zeros of a polynomial function. Thank you once again for listening, and I hope that you have gotten the knack of solving for the zeros of a polynomial function. Goodbye. See you in the next example.